Okay, in this video we're looking at factorising quadratics again, but quadratics in a slightly different form. So on the previous video we looked at factorising quadratics which had three parts to them. So something like this where you have a square part, because a square makes something a quadratic. You then had an x part, for example, and then a number part on the end. So we looked at factorising quadratics in this form where you have three parts to it. So a square part, an x part, and a number part. Okay, it might not be the letter x, but we've just used x here. And we know that factorising it means to put something into a pair of, or means to put something into brackets, and with a quadratic like this, okay, you're putting it into a pair of brackets. And we saw that to do this, it was numbers that multiplied to make 6, add to make 5, which are 3 and 2, and we saw that we could write it as x plus 3 and x plus 2. Or you could write x plus 2, x plus 3. So that was previously, you had something with three parts in your quadratic, you could saw it factorised, okay, put it into brackets where we had a pair of brackets like this. In today's video, we're looking at quadratics, okay, in a different form called the difference of two square form. So this might look a little bit complicated to begin with, but it's not, as you will see in a second. If you see something where you have a square number and you are subtracting another square number, you can write it or you can factorise it. You can put it into brackets that look like this below. Okay, so where you square root your a squared and your b squared parts and you plus and minus them. That will make a lot more sense in the example over here. So if I wanted to factorise x squared, take away 25, well, first of all, check, is this in the difference of two squares form? Is my first number a square number? Yes, it is. X squared, okay, is a square number. You're squaring x. And 25 is also a square number. That is 5 squared. Difference means you're subtracting, which we can see we've got over here and over here. So good. This thing here, x squared take away 25, is in the difference of two squares form. And when you factorise this, put it into a pair of double brackets, you root x squared, which gives you x. You then plus on the root of 25, okay, which is 5, because 5 times 5 is 25. And then the second bracket is very similar, but then you subtract instead of plus. Okay, yeah. And with practice, you'll just see that actually this is relatively straightforward. But always with factorising, how can you check your answer is correct? You can check by expanding your brackets back out. So if I go and expand this pair of double brackets, which hopefully we're pretty well versed in from our previous videos, we can see that, well, x times by x gives you x squared. X times by negative 5 gives you negative 5x. Plus 5 times by x gives you plus 5x. 5 times by negative 5 gives you negative 25. And the important bit here is the minus 5x and the plus 5x, they cancel out to make 0x, which is really important because then you're left over with x squared, take away 25. So we've checked, okay, by factorising, putting this quadratic here into double brackets, we got x plus 5, x minus 5. We can check by expanding back out to get back to what we had up here. Okay, so let's look at some examples here, okay, of factorising quadratics, putting them into this pair of double brackets. So it says factorise the following. We've got x squared take away 81. First of all, just double check, is this in the difference of two squares form? You've got two square numbers, well, x squared is a square number. Okay, you're squaring x. 81 is 9 squared, so good. And then it must be a takeaway sign, otherwise it doesn't work, which it is. And we know that this is going to factorise to go into a pair of double brackets again, where you square root the x squared to give you x and then x on both sides. And then you square root the 81, which is 9. Okay, the square root of 81 is equal to 9. Okay, and it's going to be plus 9 and then minus 9. So x plus 9, x take away 9. And that is my answer. Okay, brilliant. And again, if you wanted to, you could check that is correct by expanding back out, and you would see you get back to x squared take away 81. Good. The one below, okay, again, check, is it in the correct form? Well, you've got 9x squared. Well, 9 is a square number, and x squared is a square number, so that's good. And 100 is also a square number. So this is going to go into, again, a pair of double brackets where you square root, okay, 9x squared. And the square root of 9x squared, well, the square root of 9 is 3. The square root of x squared is x again, so 3x, and it's a at the start of both parts, so 3x and then 3x. And then what's the square root of 100? Plus is 10, sorry, so it's going to be plus 10 over here, and then over here take away take away 10. You could write it 3x minus 10, 3x plus 10, the other way around. It doesn't really make a difference. Okay? So basically, right, you square root both of your number parts and algebra parts, and then you plus and then you minus them to look like that. So there we go. Okay, so you can pause the video, you can give those two there a go, and then we'll look at, I think, one more example, and that will be it for this video. So hopefully you've had a go at these, and let's go through them. So the first one, again, double check, is it in the difference of two squares form, where you've got an x squared, which is good, you've got something squared, take away 49, which is 7 squared, so good. So we know it's going to go into a pair of double brackets. Okay, if you square root x squared, you get x, and then you get x. What's the square root of 49? It is 7, so it's going to be plus 7 minus 7. X plus 7, x minus 7. That is your answer. Brilliant. Good. Okay, the one below, we've got 4x squared take away 121. Okay, again, check. Right, 4x squared, it is a square number because 4 is 2 squared and x squared is x squared. 121 is 11 squared. So you need to be able to recognize your square numbers there. So we can put it into our double brackets like this. Make them a little bit bigger. So let's go like this. So the square root of 4x squared, well, square root of 4 is 2. Square root of x squared is going to be x, and then same over here, so 2x. The square root of 121 is 11. Okay, 11 squared is equal to 121. So 2x plus 11, 2x minus 11. That is your answer. Okay, brilliant. There we go. Not very well highlighted. Okay, good. And then finally, just to look at another example, it's the same thing again, but it's just this time what's different. You've got the number part first, and then you've got the algebra part second, but it really makes no difference. Okay, so again, right, this is going to go into a pair of double brackets because we can see, right, you've got two square things. 36 is 6 squared. X squared is a square number. Okay, so what's the square root, first of all, of 36? It's going to be 6, and that goes on both the starts of the brackets. Okay, and then what's the square root of x squared? It's going to be x, so it's going to be plus x, and then minus x. Okay, so it's just this time the number part came first because it came first in this one. But again, right, you could always check your answer by expanding back out the brackets. So if you went to go do 6 times 6, 6 times by minus x, to get 36. 6 by minus x would give you minus 6x. X times by 6 is plus 6x. X by negative x minus x squared. What happens here? These two cancel, they give you 0. You get 36. Take away x squared, which is exactly what we had up here. So you can always check your answer by expanding out your double brackets, okay, which is a good thing to do. Okay, so you can try the one on the right, and that is going to be it for this video. Okay, so again, check is it in the correct form. It is, because 9 is 3 squared, x squared is again a square number, so we can put it into a pair of double brackets. Square root of 9 is 3. You put it at the start of both brackets because it's always the a part first, which in this case is 3, and then plus, what's the root of x squared? X, so plus x, and then take away x. There we go. Okay, that is your answer. Brilliant. Thank you for watching. Hopefully that was useful.